Click the bell icon to get latest videos from Ekeeda.
Hello friends, today I'll be teaching you first law of thermodynamics. Basically, this law is an extension of something called as principle of conservation of energy. I hope you remember you all must have studied this in ninth standard. From ninth standard onwards you are studying this, okay? So this is just an extension of that law of conservation of energy. Today we are going to deal with its application in the field of thermodynamics. So we'll start the discussion with first the statement of law of conservation of energy, and it's also known as principle of conservation of energy. Okay, what this law states, it states that energy can neither be created nor be destroyed. Energy can neither be created nor be destroyed. Then what can be done? It can only be converted from one form to the another. I hope it's clear. So we can convert energy from one form to another. Like for example, if we have a fan, in that fan, electrical energy gets converted into mechanical energy, right? Okay. In a generator, what happens? A mechanical energy gets converted into electrical energy. I hope you all remember this thing. Okay. Now, coming further, energy, as you all know, that it can be converted and it can be transferred from one object to another also. Okay. Whenever energy gets transferred, there are two options. Either it can take place due to heat transfer or it can take place due to work transfer. I hope you all are familiar with these terms, heat and work. Okay. Now what we are going to do is we are going to technically define these terms, heat and work, and we'll find out a relation between heat and work done. Okay. So first we'll start with heat transfer. Heat transfer is a type of energy transfer. Heat transfer is a type of energy transfer which occurs due to temperature difference between the two systems. Which occurs due to temperature difference between the two systems. I hope you all remember, you all must have studied in your schools that heat always flows from higher temperature to lower temperature. You all must have observed also. If you keep a teacup over here, then what will happen? It will get cold. Why does it get cold? Because heat gets transferred from the hot cup to the cold surroundings. Okay, so heat transfer always takes place from higher temperature to lower temperature. One more thing is there which you all must not be knowing, but you need to remember it. It is a path function. What does it mean? It means that heat depends on the path along which it is getting transferred. You all must have studied in the previous topic some diagrams, we call them as PV diagrams, pressure volume diagrams. Okay, suppose this is a pressure volume diagram and there is a gas which is undergoing some change. Initially its pressure was P1 and final and volume was V1. Finally it became P2 and V2. Okay, now suppose there are two gases. One gas is moving along this path, path A, and the other gas is moving along the path B. Okay, so heat being a path function means that the amount of heat absorbed by these two gases depends on the path also. So the heat absorbed by A will be different from the heat absorbed by B. This is what it means. The next concept that we are going to study is work. Work is a form of energy transfer. I hope you all remember, you all must have defined it in ninth standard itself. So work is a form of energy transfer which does not require any temperature difference. Okay, it is a form of energy transfer which does not require any temperature difference. And work is also a path function. It also depends on path. Like for example, if you consider the same gas, okay, moving from P1 V1 to P2 V2, and though the two samples of the gases are following the paths A and B, then the term path function means that the work done depends on the path. So the work done by A will be different from the work done by B, although their initial and final states are same. although their initial and final states are same, but because their path was different, so the work done in both the cases will be different. The next term is internal energy. Even this term is not new for you, but still will revise. You all must have studied this in 12th standard, okay, in kinetic theory of gases. Every gas contains a lot of molecules, right? And each molecule, they are in a state of some random motion. And so because of that random motion, they will be having some kinetic energy. The sum of the kinetic energy of those individual molecules, we call it as internal energy. Okay, so it is the energy of a gas due to the motion of molecules of the gas. It is the energy of a gas due to motion of molecules of the gas. And remember, this is a point function. It depends on the state of the gas. Like for example, if you consider the same gas moving from P1 V1 to P2 V2, okay. In this case, what does the term internal energy being a point function, what does it mean? Internal energy being a point function means that the change in internal energy from this state P1 V1 to P2 V2, it is independent of the path. That is independent of the path. Like for example, A is traveling through this path and B is traveling through this path. So it is independent of that. Okay, so the change in internal energy is only dependent on the initial state, that is P1 V1, and the final state, that is P2 V2. So the change in internal energy will be the same for A as well as B. Thank you so much for watching this video. Stay tuned with eKida and subscribe to eKida.